Welcome learning normal distributions. Let's see the notes here. Previously, you have learned binomial distributions. So today, we are going to learn normal distribution. The size of the sample in binomial distribution usually are not big. If the sample size become larger, for example, greater than 30, so what will be happen if we calculate its distribution by using binomial distributions? So when the sample become large, the calculations can become complex and the values cannot be obtained from the binomial table. So when the size of samples n become large, we can estimate the answer by using a normal distributions. So how we determine whether the size is large or not? So when the mean is greater than 0, so when the mean is greater than 0, then the size of sample is large. Okay, so next, okay, look at the data that they collect and then they they draw a histogram here. Okay, they put the value and draw a histogram here. Maybe the graph will squid to the left and maybe the graph will squid to the right. Okay, so maybe it can jump up. Okay, so all the value they collect, they will draw a line here. See, they will draw a line. Okay, so no, usually we were using this, okay, this shape. Okay, what is this? This is normal distribution. Okay, so this is normal distribution and we will call bell curve. Why? Because see, look at this. It's like a bell, right? Bell curve. Okay, next. Okay, many things uh, closely follow a normal distributions. Height of the peoples, income of families, uh, s- measurements of area, size of the product. Okay, so look at the definition. Normal distribution is a probability function of a continuous random variable. So the distribution is symmetrical with most of the data cluster around the center close to the mean. Okay, so here, this is the value here. The value over here is mean. Okay, also is medium, also is mod. Okay, the value here. So left hand side, the data on the left hand side and the data of the right hand side is the same. Even most of the data isn't perfectly normal, but the normal distribution help us. Okay, so this is the data. So remember, the value of the center is the value of the mean. And this is symmetrically about the axis at the center. Okay, so look at the notation for the normal distributions. Okay, x and then n for normal. This is mean and this is variance. Okay, do you still remember the notation for the binomial? X, b, and p is very different. Okay, it's very different. So next, okay, look at the, okay, hold on, yeah. Although normal distribution function graph have the similar shape, their position and the width should be the width. The width of the graph depends on their respective means and the standard deviations. Okay, so remember the middle here is the mean. Okay, so if the value is more higher, so the graph will be on the right hand side. Okay, so the value, let's say this is 5 and this is 10. Okay, so next, okay, the width, sorry for my pronunciation, the width, okay, would affect by the value of standard deviations. This is sigma, this is mu. Okay, if the value is higher, okay, if the standard deviation is higher, the value of higher, so they will be lower. Okay, they will be lower. Okay. So means that the largest the dispersions of the normal. Okay. The more spread. Okay. Over here. Okay. If smaller, it will be higher. Okay. The height of the graph increase when the standard deviations decrease, but the mean will keep constant. It's the same. The mean will be the same, just affected by the value of standard deviations. Okay, next. Okay, click here. Okay, this is the graph that you will use it. Hold on. Okay, so this is a graph. Look at this graph. This is bell curve. This is normal distributions. The area under the x, okay, A to B. So remember, this is mean, this is median, this is mode. Okay, the value A to B. A to B. Probability. Okay, what is the probability? Where can we see the probability? Where is the probability? Here. This is the probability. The the area under the graph is probability. So if for the normal distribution, okay, for the normal distribution, the left-hand side and the right-hand side is 50%. Is 50%. Left and right is the same. So all the graph, all the area under the graph will be the one. The probability will be the one. Is 100%. Okay, look at next. Look at the question. Okay, the graph on the, hold on. Right? Okay, there has symmetrically, symmetrical at x 35. This is mean. So set the mean value. This is mean. Okay, mean is 35. Okay, so express the shaded region in probability notations. Okay, so probability from 28 to 40. So for me, even it's the same value, but for me, I will depends on the line over here. If the line is a solid line, I will I will put equal. If this is the dotted line, I will put like this. It's between 28, okay, and 42. Okay, I'm so sorry for the writing. Okay, between 28, but equal to 28, but not equal to 42. Also for the question, I will write here, this one. Even is the same lah. Okay, so next, look at the question number C. If the probability of the shared region is 0.64, so the under here is 0.64. So find the probability of the x less than 28. So let's check. Okay, so should be, hold on, yeah. Okay. Okay. Okay, so the value over here, okay, over here is 0.64. 0.64. Okay. Okay, so how to find out the answer, which is less than, hold on here. How to find out the answer for the green shaded region, which is less than 28. Okay, how to find out? So first, I got to check, is it is the same length? Okay, so I use calculator to calculate. 35 minus 28, I get 7. And then 42 minus 35, I got 7. So means that the length is the same. So probability of here will be equally divided by 2. Okay, so I divided by 2. So I get 0.332. Okay, so means that 0.32 is under, hold on. Okay. 0.32 is over here only. 32. And here only. 0.32. Okay, 0.32. So means that if we want to find out the green area, okay, green region, so we have to separate into two. Okay, do you still remember just now I just mentioned that the left-hand side and the right-hand side is the same probability, which is 50%, 0.5 and 0.5 is 50% and 50% probability, right? So the maximum of the probability is 1. So when you separate the two, is 0.5 plus 0.5. So over left-hand side, here to here is 0.5. So means that total under, hold on. Okay, total the probability under the green line, okay, under the green line is 0.5. Okay, is 0.5. I need the sorry, this is blue line. Total the area under the blue line is 0.5. So I want the green line. So I using 0.5, not green line, green region, 0.5 minus 0.32, right? For P, which is green regions, is 0.5 minus 0.32. Okay, so I get 0.18. Okay or not? Okay, look at the next question. Okay, a continuous random variable x. Okay, where this is what? This is mean, this is variance. So find out the mean. Mean is 2.3. Find out the standard deviation, but this is variance. So variance equal to 0.16. So standard deviations is 0.4. Okay? Okay, yeah? So do the exercise, please. Yes? Okay, see you tomorrow. Bye.